Alright, so here's my next project that showed up here a few days ago. Friends, I believe 2016 Jeep JKU 4-door. It's thing's been pretty reasonably built so far. It's got body armor, bumpers, winch, sitting on Rubicon Dana 44s, the stock Rubicon air lockers. It's not in too bad a shape. Looks like, it's been used, but pretty decent rig overall. Definitely got himself some light bars on there, so that's always good. That gets you through a trail. The problem we've run into with it, though, we found pretty much right here. That's a 40-inch tire on a Dana 44. That's a combination that doesn't end well, one way or another. So we're going to fix that. So the way we're going to fix it, find right here. This is an 05 up Super Duty Dana 60 front end. When he bought it, it already had the reed knuckles and high steer arms on it. It's got a 513 gears in it, ARB air locker, and working on putting on this Motobilt truss that's actually a conversion that allows this axle to bolt up directly in place of the Dana 44 that's in there right now. I've already started working on this, got it kind of tacked in place. These things are pretty decent. They're just a slot and tab setup. You just put them together, tack them up, make sure everything fits right, and then weld them on. So this axle already had all the original forward brackets and everything removed, which is nice. So those are a pain in the ass to get off. Just a lot of time and a lot of grinding. For the rear end, going with this 14 bolt. This is actually off of a 2007. So it's a little bit different than some of the ones I've dealt with in the past. It has the factory disc brakes on it, so we're going to be adapting those to work. And it's also going to be getting the Motobilt JK conversion truss. So far I've just got all the stock brackets and everything cleaned off of it and got it ready to go. So that's where we're starting from, and kind of work you through the process of getting the truss set up on this axle and go from there. So here are the components of the Motobilt kit. Basically standard laser cut pieces, 1/4 and 3/8 plate. You got all the brackets to hook up the factory control arms, Panhard bar, all that stuff. It's got a pinion guard. The pinion guard basically determines the location for everything else. So once that's bolted on, the top plate bolts to it, everything else welds into place. There's really no guesswork as far as where everything's got to go. It only has one place it can be once it's all bolted on. So first step on this, they've got some weld washers that need to get welded on, and then we can start fitting up the rest of the plates and see how it all works. So these are two of the weld nuts that go on the bottom side of the main plate. They just pop into a hole like that. Already in there, they slide in, weld up, and then once this is flipped over and on the axle, you can bolt down right to it. There's also a pair that go on. So these are for the top of the coil spring mounts. It gives you a place to mount a coil retainer too. So I also wanted to dry fit this as an assembly before I tack it together. I think it's going to be easier to tack this thing on the bench and then put it on the axle. Also, up under here, you've got no real good way to access that once it's on the axle to weld it in, since that's where the strength is going to be coming from tying into the pinion support. I think welding this up on the bench is probably a pretty good idea. Alright, so I got this thing all tacked together. Got a couple of good solid welds up underneath that pinion support I wouldn't be able to get to once everything was installed. So now we'll go ahead and drop this thing back onto the axle and see how it fits. Alright, so I moved this thing over on the bench, make it a little easier to deal with so I'm not bending over, killing my back trying to work on this. Stuff is all heavy, so the easier I can make it, the better it is. So we'll go ahead and start trying to fit up this truss and see how it goes together. So first step, put that on there, get it kind of generally located where it's going to go. This thing's going to be located by this piece, bolts onto the pinion support, and then it's going to bolt onto the top of the truss. So we'll run some bolts in this. And we'll drop the bolts in here. And I'm going to run nuts on a couple of them just so everything stays tight. Alright, now that's got this thing located exactly where it's got to go, so we can start tacking it on. Alright, our next step is to get some of these bracket assemblies welded up before they actually go on the axle. Start out with these lower link brackets. They get the shock mount and the sway bar bracket welded to them. Comes with this little plate here. So with that, it bolts onto the bracket itself, and that's going to locate where these brackets go on this mount. So we'll get this snugged up. And then the shock mount, it just fits into one notch like that, and the sway bar mount is going to mount up into that notch like that. The other one we're going to weld up is this track bar mount. It's a two-piece mount, so just drops in. You can't get to this when it's on the axle, so we'll weld it up before we put it on, and then it'll be good and solid once we get it in there. Alright, so I got these all welded up. I also went ahead and welded up these coil brackets, just have a little weld washer in them. Welds onto the top of this tube. That's going to wind up sitting right in here. So you have a coil retainer where the spring sits on there. The other thing I found when welding these up, you can see it's way wider at this end than it is at this end. This is about 2.5, this is almost 3 inches. So when I weld these on, I'm going to have to clamp that down, get that down to the appropriate dimension before they get welded on. Otherwise, I'm going to be fighting this the whole time when I'm actually mounting up these brackets. So I think the first thing I'm going to do, since the axle's already in the right position, is you've got these upper link mounts here. Those are just going to go on, key on just like that, and get those tacked on, and then probably flip the axle around and get the rest of these brackets tacked on as well. So there it is, all the brackets are on, everything's ready to be welded up, and kind of fit just like it's supposed to on there. So now I'm just looking at a few hours of welding up this one and the 60 for the front, and I should be getting pretty close to ready to start tearing the Jeep down, see if these things actually fit under there. Right, so I went ahead and pulled the axles out of this thing. I didn't bother to record any of that. It's just all normal nuts and bolts, so nothing too much to see there. Everything under here is pretty standard stuff, so now we got a nice blank slate to start working with to try and get this 1-ton stuff under here. See how that all fits. Alright, so I rolled the axle underneath here in the front, start hooking up links, seeing how everything's going to fit. There's been a little massaging that's had to happen to kind of figured there would be. The biggest issue is that the brackets on the new axle sit wider than on the old axle, just because the axle's wider. So I'm going to have to do a little modifying on these links, make that fit. And because these stock length links are only going to be temporary, eventually this is all going to get replaced with a long link. We're going to do this a little bit hack. So this is basically just, I'm going to cut probably 90% of the way through this. We'll bend these into the shape they need to be, and it'll get welded and reinforced to make it last until the long arm kits gets put in. Alright, so you can see with that cut, able to bend it, open that up a bit. So before this all goes back together, I'll take the grinder and bevel this all out and weld it up good, so it should be good and solid for the use this is going to see until the long arm kit gets put in. Time to get back on this Jeep project. Last time we did, got the axles roughly hung under there. So I've got them kind of hanging close to ride height right now. I need to do something with the Panhard bar. With the way this allows you to move the Panhard up, which I really like. So actually, the higher the Panhard, the more stability you can get. It raises up the roll center of the suspension. Takes a little leverage off the thing wanting to roll back and forth versus having it down at the stock height. So with the stock Panhard up here, it would come up and make contact with this cross member up here. It's got that big hoop in it. So this is the big hoop I'm talking about. It's made to clear that the front axle housing with the Panhard in the stock position. The Motobilt kit moves this in forward a bit, so that's not an issue anymore. So we've kind of chopped that off, and this is what we came up with. So I took the end I cut off, turned it down. It's going into a piece of 1.5 inch quarter wall tube. And the other end, I'm putting a 3/4 inch heim. The misalignments on this were a little too wide to fit that bracket, so I just turned this off. Basically, it'll bias this thing forward, give me a little bit more room to work with as far as clearance from the bar to the diff cover. Everything looks like it should work, so we're going to give it a try. So here's what it looks like at roughly ride height. Not too bad of an angle on it, and we'll run it up to full bump, make sure I've got clearance there. Pretty sure I will. And here comes a slimy wet dog. And here it is at full bump. So see, it gets pretty tight there, but there is still clearance. So what I may end up doing is just putting a bend in this thing right here, just a slight bend up there and give it plenty of room. But for right now, I think I'm just going to weld this up and call it good for the moment. There we go. Got Panhard bar all welded up and installed. So it looks like that's going to work out pretty well. That kind of, apart from final installing springs and tightening everything up, that basically finishes off the suspension on this thing. So now it's time to move on to drive shafts. These are the basic parts we're going to use for the drive shafts. We got 1350 CVs for both front and rear. Got these yokes, came from Adams drive shafts. So those, and then it's going to be a 1350 slip in the front and a 1410 in the rear, just to match up with the yokes that we already have on the axles. So these right now are both set up for a 2.5 083 wall tube. For me, I kind of consider 120 wall kind of the bare minimum for an actual off-road used drive shaft, especially something that's going to be used in the rocks quite a bit. So I'm going to throw these and the slips in the lathe, and we'll get these turned down to fit a 120 wall shaft. This is a setup we're using to turn the CV head. So I've got the yoke chucked up in here. Fortunately, these things come with a center hole in there already for the live center. So now it's just a matter of turn that down to the appropriate dimension to press into the 2.5 120 wall tube. Should be easy enough. These parts are ready to go now, so I just need to measure up for the tube that they're going to need. To do that, I just set a tape measure up on the bench, take the one end, set it up to where the edge of the bench is at the center of the joint, pretty much there. Got enough slip exposed for the amount of travel we need. This one being the front shaft is going to be 34.5 inches. So I'll set the center of this joint up to 34.5 inches. And I can measure the length of tube I need and go get it cut. I've got my piece of tube all cut and deburred, ready to go. I generally like to stick this end in first, just because it's easier to get the slip lined up with these rather than trying to line down this end. You can't, makes it hard to see which direction the joint's really facing in, so I just like to put these in first. This is my basic setup for straightening and welding on these. I don't have a good way to actually hold with the slip yoke on at this end, so just typically use the center and the end of the stub. It so far has come out pretty good on the shafts I've built. So we'll just rotate it in here. So this one's pretty close already. We'll get it tapped straight, tack it up, same thing at this end, and then we'll weld it up. Now that I've got it all welded up, got the indicator set back up on it, we'll see where we ended up at. Looks like we got 5 or 6 thousandths run out. So we'll go ahead and fix that. So just roll this up to the high spot right there. So what we'll do is just heat up a spot with the torch right here at the high spot, quench it. That'll make that area kind of close down and get rid of that high spot. All right, here you can see with that, we got that 5 6 thousandths down to 2. So I'm going to call that good. That's about as good as typically get. Every once in a while you get perfect and they come out zeros, but this is definitely good enough. And you know, a lot of people want to say that this is going to heat treat that and make a hard spot, but this is just 1018 steel. It does not have enough carbon in it to heat treat, so you can run a file across that right now and it's still going to bite in. It's just as soft as it started. And I got the slip yoke installed, got U-joint installed in it, got the shaft all polished up, ready for paint. So now it's just rinse and repeat for the rear drive shaft, and one more thing done on this project. I've been working on the steering on this Jeep a little bit. So the owner had this kit that I think was for the original axle just by the way it's marked. But I was able to extend it out far enough to make it fit with this Dana 60. There is still, there's at least 1.5 inches or so of thread up inside the tie rod still, and it's 1.25 inch thread, so it's plenty stout. I just wound up making some bushings. So basically bored out the knuckle, made a bushing to take this taper, and welded that into the knuckle so that these tie rod ends would work on this knuckle. Now I'm working on making the drag link. So I've got this kit from Rough Stuff that has the 1-ton tie rod ends, the jam nuts, the tube inserts, and a piece of tube. So I've got those, see, on both ends here. The problem is the angle of the drag link right now is not matching anywhere close to the angle of the Panhard bar, so you wind up with bump steer. Here you can see what I'm talking about. I've got the tape attached to the tie rod end at the steering box and at the knuckle, and you can see the difference between that angle and the Panhard bar angle. So what I think I'm going to do to try to solve that is take this tie rod end and put it on top. So basically just re-taper the pitman arm for the tie rod end to go on top, and I'll have to probably bend it down a little bit so I've got clearance to the frame when it steers. But by doing that, see, it's a little tough to tell, but anyway, it's going to get it a lot closer to this angle. It's ideally, if I was building this all from scratch and wasn't trying to work around stock suspension stuff, I would move this end of the Panhard bar somewhere over here so that it would all match up better and just have less difference between the length and the angle on the tie rod and Panhard bar. But with the coil spring sitting right there, it kind of limits what I'm able to do. So for right now, I think, like I said, if I can just take this, flip it over, put it up on top, that should give me close enough to an angle that this thing should have some pretty decent road manners. Okay, so we got the Panhard mount all welded up and painted. So now that the pitman arms had time to cool, we'll go ahead and get it installed on here, and then we can check where our angle for our drag link is and measure up, see how long a piece of tube I need for it, and get it made. Alright, so here's the pitman arm installed. You see we've got just enough clearance over the top of that tie rod end to clear the frame. One thing I did discover, I was just centering this thing up, making sure the steering box was centered before I measure for the drag link. When this thing trying to turn to the left, the pitman arm is hitting on this bracket, so I'm going to have to cut a little clearance into that. But for right now, the box is centered up so I can measure what I need from this tie rod end to that one. And here's a little bit more of a visual on how close the angle between the Panhard bar and the drag link are. The lengths are a little different, so there's going to be a little bump steer at the extreme ends of travel, but for just driving down the road, this thing should be fine. Alright, so here we've got my tube cut, got the ends set in it for right now. I'm going to pull these ends out before I weld them into the tube. It's a lot easier to fix a burn through right here with this out than if you'd welded it with this in, because now they're pretty much one piece. With these ends, the 7/8, see the end of it's real thin where it goes in, so you got a solid chance of being able to burn through that. So pull the tie rod ends out, get this welded up. Alright, so I've got the drag link all welded up and painted. So while I'm waiting for the paint to dry, I'm going to address the pitman arm hitting right here. So I've kind of made a mark here where I'm going to cut this out. I think that should give me enough clearance at that point that the pitman arm can go through its full swing without making contact. So we shall find out. Alright, so now I can take the grinder, clean that up a little bit, make it look like it's supposed to be that way anyway, and shoot a little paint on it, and we should be good to go. All right, so there it is, all clearance, ready to go. Lets the steering box go through its full range of travel, so should work. We'll squirt a little paint on it and call it good. All right, so my next problem has just reared its ugly head. You can see, because of the shape of this pitman arm, when I'm turning to the left, even here close to ride height, this jam nut is getting into the pitman arm here. So solved one problem, created another one. So I think what I'm going to wind up having to do is probably put this back underneath here, and I'll have to figure out what I'm doing different down on that end. So yeah, I'm going to think on that one for a little while, see what I come up with. All right, so I've solved my steering problem. See, I moved the tie rod end on the pitman arm back to underneath, actually the pitman arm back to where it was to start with, so that was fun. And then on this end, you can see I've got this block that I made up that's tapered for the tie rod end and then welded onto this tie rod end. Not ideal, but I don't think it's going to cause us any issue. You can see I've got a good solid 2 inches of weld there. It's things on there, it's not going anywhere. The other nice part about these tie rod ends too is I don't have to worry about replacing this at any point, because there's just this cartridge here unscrews, comes out of it, that can be replaced. So this part of it is permanent. So I think this is going to solve my problems. It gets my tie rod and, or my drag link and Panhard bar, still not perfect, but they're pretty close. I think it's going to work out reasonably well. All right, well, we've pretty well got the front end finished up now, apart from installing the air locker hose and tightening up a few bolts. It's pretty much good to go. So now it's time to move on to the rear end and see what we got to do there. So one of the things I need to do on the rear before we get it finished up is I've got this kit from TMR for putting this speed sensor in. You can see it. It's going to go onto the back of the hub, but I'm going to have to machine the hub for that before it'll fit on. And it basically uses the original Jeep speed sensor in this bracket. Makes it so your ABS and all that still works. So you have to turn this down. In order to turn this down, I got to pull out one of these studs. So I'll knock that out here real quick. All right, so here we get the hub chucked up in there. You can see why I had to pull a stud out. It's because there's no room, you know, with a 3-jaw chuck and an 8-lug hub. It's kind of just the way it works out, but it's easy enough. Also, while I'm turning this, I've got the hub packed with some just packing paper to keep any chips from getting into the bearings or anything like that. Just help keep it a little cleaner. Alright, so this ring that needs to go on there is about a 1/4 inch thick, actually pretty much exactly a 1/4 inch thick. So in order to get my depth right on that, without having a DRO on this thing, so I just touch off with the tool on the face of the hub, and then I just get an indicator on the carriage, so I'll set that to a 1/4 inch. When that reads 0, I'm in the right spot. So I'll go ahead and get this thing turned down, and we'll go from there. Alright, so I've got this turned down to where it's basically just a couple of thousandths press fit for this ring. So in order to avoid putting too much pressure one point or another on this thing while pressing it on, I'm just going to heat it up a little bit, once it's heated up, it should just drop on, and then when it cools down, it'll be nice and pressed. Alright, there we go. Now when that cools down, it'll have a nice secure press fit. Won't go anywhere. Alright, so I got both of them done now. You can see once everything cools down, that thing's not coming off. So, should work out good. Next step is to get these brackets installed, which means that the brake caliper bracket's got to come off, and there's got to be some modifications done on the housing itself. We'll get to that. All right, so I've done the modifications on this backing plate and the housing itself. You can see it's just a notch right here and then a hole for the speed sensor to go through. So that's just going to go something like that. I'm actually pointing at what I'm trying to show you. It'd be helpful. Then you can see the speed sensor. And it pokes through that side, and we'll read that ring we just put on the hubs. All right, so I went ahead and assembled pretty much everything else on the rear end. Got the brakes all put in. I also got these spacers / adapters, taken from 8 on 6.5 to 8 on 170 to match up with the front. This will also make the width between the 14 bolt and the Dana 60 front match up. So about the only thing left to do back here is get brake lines hooked up. And you kind of see the original calipers were on the rear of the axle, and on the 14 bolt the calipers are in the front, so that doesn't quite reach. So what I think I'm going to do is disconnect the hard line off the frame here, probably put a bend in it right about here where this bend is, and bring this around up to the front, and then drop the brake line down to the caliper. So now, I want to take this thing and just kind of bend it back around to get this line up to the front of the axle. And here we go. After a little reworking of the brake lines, comes down, it attaches to the calipers. The nice part about banjo connections is they're fairly interchangeable, so the Jeep brake line goes right onto the GM caliper. So now I just got to put a hole in the frame right here for this bracket to bolt to, get that all attached, and this part's done. Alright, there we go. Now I just gotta do it all over again on the other side, and that pretty well wraps up this rear end.